Does slicing a, e.g. a, 1, smiley face equals a, :1, create copies of the a? A friend of mine showed me the following Python code, which returns true if all the items in a are identical. I argued the code is hard to understand from first sight, and moreover, it is inefficient in memory usage, because 2 copies of a will be created for the comparison. I've used Python's dis to see what happens behind the hood at a, 1 column equals a, column minus 1. It boils down to 2 slicing commands, slice +1 and slice +2. The documentation is unclear as to whether these opcodes actually create a new copy of a, or just a reference to it. Does the slice commands copy a? Does the answer varies between Python implementations, Cython, Jython? Update. This snippet is clearly unreadable and confusing, and I'm not going to ever use it in actual code. My interest is purely technical, whether slicing copies the list, and whether the answer varies under different circumstances.
The documentation is unclear because slicing different objects does different things. In the case of a list, slicing does make a shallow copy 1. Note that this is a feature of Python lists independent of Python implementation. In the case of other objects, like numpy arrays, it might not create a copy. If you want a better way to check that all the elements in a list are the same, I would probably recommend. From a performance standpoint, your friend's code might actually outperform this for small lists since list slicing is so optimized. But, this is much easier to tell what is going on and has the opportunity to short-circuit as soon as it finds a non-match. The actual function to look at is list_subscript, but for most cases, it just calls list_slice.
If a is a list or tuple or string, len a is n, and n is greater than 0, then each slice creates, at C level, a new array of length n1. At C level, all objects in Python are implemented as pointers, so these new arrays contain n1 pointers copied from, well, not really for strings. The string representation is more frugal, but, as at Gilson said, what slicing returns is up to A's type. Some types may return a compact descriptor instead of copying anything, and a type may even implement slicing in such a way that the code shown wouldn't work as intended. But you really had a list in mind, winky face.
For vanilla lists, slicing does create a copy. You can prevent the copy using iteration instead. The line i1 equals i2 for i1, i2 in itatools.zip, a1, a2 creates a generator that will return whether each element in a is equal to the next, one at a time, to all. The results are evaluated one by one instead of being put in a list first, so you save memory at the cost of some performance.
Yes, with list objects Python creates shallow copies when slicing, however the loop is made in C, for Python, and for that reason is going to be much faster than anything you can write in Python for doing the same. Looping 2 times in C for the shallow copy and looping again for comparison is going to be faster than just looping in Python once. Please remember that Python is quite often fast enough, but that Python code is still about 100 times slower than C code. Leaving Python doing the loops for you is therefore better in general if you want a bit of speed. Note that even things like C equals A plus B in Python mean the execution of a lot of logic, including branches and memory allocations. On the other side, however, if for your code this kind of micro-optimization is fundamental, then probably Python is not the right tool for the problem you are fighting, and you should consider other options, like writing a small C++ extension interfaced with SIP, using Cython, pypy. For sure that code is not readable for the untrained eye, and in case the list is long and often not constant, then all y equals x 0 for y in x is going to be faster because of short-circuiting, even if the loop is in Python and an extra subscript operation is done for every element. Readability counts a lot. Edit. Another interesting option for having C code looping over the elements is this doesn't offer short-circuiting, but on my PC is about 75 times faster than the all-base solution for a list for 1000 elements, all of them equal, and about 6 times faster than x, 1 column equals x, column minus 1. I find it also a bit more readable than x, 1 column equals x, column minus 1, but it's probably a matter of taste.
If you want to support the channel, please consider liking and subscribing.